Hello, my dear students. I want to solve in this video a curious exercise about friction. So the first exercise is a 42 Newton force is needed to slide a 30 kilogram box across a flat surface at a constant velocity. So what is the coefficient of kinetic friction between the box and the floor? So we're going to make a sketch of the problem here. So here we have the horizontal surface, and we have our box here with a mass of m of 30 kilograms. So m is the mass and is equal to 30 kilograms, right? Now, when we analyze which are the forces that are acting on this body, well, we know that we need an applied force of 42 newtons to make this body to move. So we have here a force applied equals to 42 newtons. And of course, there will be then a force of friction that is going to oppose to this force, right? And here we have then the force of friction. In this case, right, as we want to move the box, right, and the velocity will be constant, right, well, we have that the net force needs to be zero. And while the box is moving, the force of friction that is acting is the force of friction kinetic. So we don't know this force of kinetic friction, but if we know that in this case, the velocity is constant, then the net force needs to be equal to zero. And this net force is basically the force that you apply minus the force of friction kinetic, and needs to be equal to zero. So the force that is being applied needs to be equal to the force of friction kinetic, right? And all this is because we know that the box is moving with constant velocity, right? So there is no net force, right? The net force is zero. So the force of friction kinetic needs to be equal to the force that we apply. Now, what else we know? Well, we know that there is a weight acting downward that is equal to the product of the mass times the gravity, right? So we can calculate the weight, that is mass times gravity. So it's 30 kilograms times 9.8 meters per second square. Okay, that will be the weight. And if we calculate that, it would be 294 newtons. Now, we have a force that opposes to the weight. That is the normal force, which is a supportive force, perpendicular to the surface. So this is the force normal. So now we know, okay, that the normal force, if you make a sum of the forces in y, and you know that that sum of forces in y is zero, and you take positive the forces pointing up, you can say that the normal force minus the weight is zero. So the normal force will be equal to the weight, and will be equal to 294 newtons. Well, the question here is about finding the coefficient of kinetic friction. So what is unknown here is mu sub k, the coefficient of kinetic friction. And then we know that the force of kinetic friction is equal to this coefficient of kinetic friction mu sub k times the normal force. Well, we know the force of kinetic friction because it's equal to the force that we apply is equals to 42 newtons. Okay, so here we have the force of kinetic friction. We know the normal force that is equal to the weight, and is equal to 294 newtons. So we can solve for mu sub k here. And we have that mu sub k will be equal to the force of friction kinetic divided by the normal force. So the force of friction kinetic, which is 42 newtons, divided by the normal force, that is 294 newtons. Of course, the newtons cancel out. Mu sub k is a dimensional, and we will get that mu sub k is 0.143, or approximately 0.14. So here we have, with two significant figures, the value of the coefficient of kinetic friction. The second exercise is a little bit different, because in this case, there would be acceleration, right? So they say a 60 kilogram box is being pushed along the horizontal surface. The coefficient of static friction between the box and the ground is 0.65, and the coefficient of kinetic friction is 0.45. What horizontal force must be exerted on the box for it to accelerate at 15 meters per second squared? So let's analyze again. You know what is going on here. So we have our horizontal surface. We have the box with mass m, right? We know that this mass m is equals to 60 kilogram. We have a force that we would apply pushing this box. And then we have a force of kinetic friction, because this will be moving. So when it's moving is kinetic friction. So we have a force of friction kinetic here, opposing to the motion, right? But the problem is that there is acceleration. So look at this. They say the box will accelerate at 1.5 meters per second square. So what we don't know in this case, or unknown in this case, is this force that we apply. Of course, we know there is here, you know, the weight. There is equals to mass gravity. And this weight will be mass gravity, so it will be 60 kilograms times 9.8 meters per second squared, which is, in this case, 588 newtons. We have here also this normal force pointing outward, supportive force, you know, is the force that the ground hurts on the, the ground hurts on the surface, hurts on the block, on the mass. And we know that this normal force, by making a sum of forces in y, and we know that there is no motion in y, so we know that this sum of forces in y will be 0. Then we have, you know, that the normal force will be equals to the weight, right? Why? Because, well, we can say normal force minus weight equals 0. So normal force equals to the weight, so the normal force will be equals to 588 newtons here. Okay, so now we know this normal force. Now, what we know we know that there is an acceleration, and we know that we have two forces that are horizontal. So we make a sum of the forces in x. And this sum of forces in x is equal to mass times acceleration. And I will be taking positive the forces pointing to the right. Acceleration in x, a sub x. Now, which are the forces that we have in x? The applied force minus the force of friction kinetic is equal to mass times the acceleration sub x. We want to solve for the force that we apply. So the applied force is equal to the force of friction kinetic plus the product of the mass times the acceleration in that direction. So now we know that the force that we apply will be the force of friction kinetic will be mu sub k times the normal force plus mass times the acceleration in x. So now we substitute and we get mu sub k, coefficient of kinetic friction 0.45, times the normal force 588 newtons. Let me just rewrite the number. 588 newtons plus the mass 60 kilograms times the acceleration 1.5 meters per second squared. So now the force that we apply will be, when we calculate this, it will be approximately 355 newtons. If we want to rewrite this with two significant figures, as most of the data that was given, we can round to 360 newtons. We have a third exercise here. It's a wooden block slightly directly down an inclined plane at a constant velocity. So again, we have important information here. We have a constant velocity of 6 meters per second. Right? So how large is the coefficient of kinetic friction if the plane makes an angle of 25 degrees with the horizontal? The angle of repulse, there is the maximum angle at which the block resting on an inclined surface stay at rest is equal to the tangent inverse of mu sub s. Is equal to the tangent inverse of the coefficient of static friction. This is the maximum angle for the block to stay at rest. Now, the angle that we call zeta prime, at which the block would be sliding down with a constant velocity, would be equal to the tangent inverse of mu sub k. And this is the angle, for the block to slide down at constant velocity. So if I want to find mu sub k and I know that angle, because they say that is sliding down at constant velocity, you know, and then the plane makes an angle of 25 degrees, you can say that mu sub k is equals to the tangent of this angle zeta prime. So it's the tangent of 25 degrees. So it's basically, you find the tangent of 25 degrees, you get your calculator, and you find 25 in degrees tangent, it gives you 0.466, so approximately 0.47. So this is the coefficient of kinetic friction, you know, of the surface when the angle to have the block sliding down at constant speed is 25 degrees. But there is another way to calculate this coefficient of friction. That would be by making a sum of the forces, right, that we have across the inclined plane. So I will show you then a second technique to do this. So we'll add one more slide here. And what are we going to do? We have here the inclined plane. I will show you this because if there is no constant speed, then this is the same technique that we use. We have the angle here that is 25 degrees. We have the block here at the top of the inclined plane, right? And then now we have that the weight is acting like this. So downward, perpendicular, sorry, vertical, downward. And the weight, you know, of course, is going to be equals to the mass of the block times the gravity. Now, there is another force that is the normal force that we know that is always perpendicular to the surface of the incline. So the normal force will be acting in this direction. Now, you can break down the weight into components. So you will have one horizontal component of the weight that will be pointing in this direction. Sorry, one horizontal component, no, one component parallel to the surface of the incline. We call this y parallel, or the W parallel. And you will have another component that is going to be perpendicular to the surface of the incline. That I will call W perpendicular. Now, the angle of 25 degrees you have between the horizontal and the incline is the same angle, you know, between the vertical and the perpendicular component to the incline of the weight. So this is also 25 degrees. So based on that, I know that the parallel component of the weight will be W, as is the opposite side to the angle of 25 degrees, sine of 25 degrees, while the perpendicular component of the weight will be, in this case, W cosine of 25 degrees. At the same time, we have here an orthonormal force that opposed to the incline, the motion of the incline of the block sliding down the incline. So here we have the force of kinetic friction. And we know that the force of kinetic friction will be mu sub k times the normal force. So it would be mu sub k times the normal force is equal to W perpendicular. So it's equal to mu sub k W perpendicular. So it's mu sub k W perpendicular is W cosine of 25 degrees. And W is mass gravity, so it's mu sub k mass gravity cosine of 25 degrees. This is the force of friction kinetic. Now, W parallel, we know that is W sine of 25 degrees. So it's mass gravity sine of 25 degrees. Now, they said something interesting here. They said we have a constant velocity of 6 meters per second. So that means that the net force in this case parallel to the inclined surface is going to be 0. So that means, right, that we can say that the difference between W parallel minus the force of friction kinetic is going to be 0. So we can now substitute then. So we say that, well, first we say that W parallel is equal to the force of friction kinetic. What is W parallel? Is mass gravity sine of 25 degrees equals to, what is the force of friction kinetic? Mu sub k mass gravity cosine of 25 degrees. Mass and mass cancel out, gravity with gravity cancel out. Then we have the sine of 25 degrees equals mu sub k cosine of 25 degrees. Solving for mu sub k, you get sine of 25 degrees over cosine of 25 degrees is equal to mu sub k. And sine of 25 over cosine of 25 is the tangent of 25, so mu sub k is equal to the tangent of 25 degrees and is equal to, as we did, we have calculated before, 0.47 approximately.